Hey everyone, Alex here again. Our next CactusCon talk is the full purple juice, not the watered down stuff, which is brought to us by George Orchies, who's a CTO of Scythe, and Bryson Bort, who's the founder of Scythe. After the talk, stick around for a live Q&A with George and Bryson. Just go ahead and click the link that pops up on your screen. Enjoy the talk.
All right, hello CactusCon. Welcome to what we call Motorhead. So we always like to use little 007 names for our different projects for our customer privacy. And in this case, the client actually let us share not only who they are, so thank you to the National Motor Freight Traffic Association, but they were willing to let us go out and share the technical details of a full Purple Team engagement. Now, I'm sure some of you have heard about Purple Team. Some of you might have done Purple Teams, but this was a 6-week on the ground engagement for Purple Team. I've never actually heard or seen one this big. So we're really lucky to be able to share this.
Yep, very happy to be here. Of course, we're not going to make this a sales presentation. We're going to talk mostly all technical data. And again, shout out to the folks that let us talk about this, because most of the time we have to show fake data, and this time we get to show real data. And as usual, we hope that what you learn here today can be used immediately at work.
All right, so hi, I'm the unicorn, Bryson. I founded Scythe, which was a spin out of the consultancy I founded 8 years ago called Grimm. And then I'm the co-founder of the ICS Village nonprofit.
And I am George Orchies. I'm the Chief Technology Officer here at Scythe. I've done some industry contributions like the Purple Team Exercise Framework and the C2 Matrix. Prior to Scythe, I ran the offensive team at Citi for 10 years. And I also teach for SANS and am an author of the Red Team Exercise and Adversary Emulation course. So today we have an agenda as usual, real quick executive summary. So you see what we did and hopefully find that valuable and don't drop off and go to another track. And then we'll go through the Purple Team exercise. It was a 6-week long exercise. Every week was a different adversary that we emulated, and then also did detection engineering to figure out how to detect and respond against that threat actor. So 6-week long exercise. We did do assume breach scenario. Assume breach means that we know and our client knows that they are going to be compromised, which means that we started with initial access. We did not focus on things like phishing or exploiting some vulnerability on their perimeter or anything like that. We started inside, which brings a lot of value. If you've not heard of Assume Breach before, definitely check it out. It's definitely high value in the offensive space as well. And we did this as a Purple Team exercise. That is multiple teams working together. Lots of people think it's just red and blue. That's it also includes the cyber threat intelligence team, which provides information about adversaries that are likely to target the organization. The red team is the offensive team, and then the blue team are the defenders. We came into this organization and they asked us to actually perform all 3 roles and to pretty much improve their security with $0 technology spend. Only work with the tools we had available. So this was a really unique opportunity, and we're very happy that they're allowing us to share it here. So what did we emulate? Well, week 1, we went in there, new environment for us. We wanted a baseline, really understand what controls they had, how far an attacker would get. Like, can we even set up a C2 channel out to the internet? And if so, what visibility do they have? So week 1 was pretty much baselining and getting a sense of all the detective controls that they had and kind of see where we were. Then we started upping the sophistication level. Week 2, we did APT-19. Week 3, we did bug trap. Week 4, APT-33, and week 5, APT-3. And then on the last week, we took everything we learned and any gaps that we saw that we hadn't tested, and we tried those out in what we call free play.
So threat detection is hard. All right, first, I want to give a shout out to Anton Chavakin, link down there at the bottom. First thing to note with our slides and the way that everything we do, we are going to give credit to everybody that we are working with. We want to make sure that they, first of all, give credit to your sources. Second, this is going to help you, the audience, to deep dive. 50 minutes goes by really quickly with the amount of information that we have. And so we have to gloss over a lot of things. And so we want our presentation to be available afterward to give you lots of ability to go run down the rabbit hole. So first problem is why detection is hard is that attackers are always changing, right? And in some cases that's at the payload level where payloads are going to be polymorphic and are going to be changing on their own. They're also going to be continually changing their C2 capabilities. And that can be anything from the ability to swap out protocols to make it more difficult to changing how they're calling out so that that's always different. The other element is they're always going to be changing their tactics, techniques, and procedures. What worked before will stop working. And so they're always going to just take the little pieces and keep evolving that to stay just ahead. The key is, of course, we want to improve the detection via alerting. Step one is logging. Can I see it? Step two is that log being given context to say, hey, this needs attention for human intervention. So this is where we take, can a tool see something, to when can it bring our security staff to be able to identify, respond, and remediate the challenges. Part of what makes this so difficult is putting these things in context. When is a screenshot benign versus when is a screenshot malicious? On one hand, a screenshot is what we all do almost every single day on our computers for various reasons. The second is an attacker trying to steal credentials. How do you put that in context so that that log becomes an alert to do it? It's worth noting that in the top 10 OWASP is insufficient logging and monitoring is one of the top 10 vulnerabilities. So this entire Purple Team exercise is great because it's a collaborative, milestone-driven approach where we're taking specific attacker TTPs and we're walking them through the entire security stack of people, process, and technology to make sure that we have context to be able to respond to all of this. The final shout out I want to give out is to somebody who I call one of the smartest people in cyber, and that is Sunil Yu. So he created this concept a few years ago called the Cyber Defense Matrix, and that's what we're seeing here on the screen on the right. The Cyber Defense Matrix is this ability to look at my assets and users in my organization through the phases of defense. My ability to identify a threat, protect my things, not identify a threat, identify my assets. And then where this really comes into what we're doing at the Purple Team is protection, detection, response, and some amount of recover is the scope of what we're going to be doing. So, former Army officer, everything has to be simple. I break down all of the phases of an attack into three: reconnaissance, access, and post-access. They're casing me and getting intelligence to build a mission package to attack me. Access, they're trying to jimmy the locks and get into the house. Post-access, this is where they're in the house and they're doing something. So this is an area where we get a lot of confusion in terminology and offensive assessments. Penetration testing is an access component, right? Penetration testing is looking at system hardening, configuration errors. What's my ability to get shell? Post-access is what happens next, because you don't pop shell, drop mic, and walk out. You pop shell and start thinking, what do I do now to accomplish my goals? What code can I put down after however I got shell to accomplish my goals, right? And the other thing is I'm not always where I want to be. In fact, most of the time an attacker isn't sure where they're starting. Attackers don't know everything, right? I didn't land here, got shell, and immediately know the entire network. I have to start figuring out where am I compared to where I want to go and what do I want to accomplish. The other thing I'd like to point out, so I was having a conversation just a few days ago with somebody and they were like, yeah, we kind of did a Purple Team once. And what we did is, and what it was essentially a very limited penetration test, but it was done in a collaborative approach. You can do a purple team at any one of these phases. The key part here, and this is why we add the blue graph showing the increase in business value, is that there is the greatest business value, of course, in understanding what happens in the post-access environment. That's the part where I can steal something, I can break something, I can change things. This is what we really care about from a business perspective, but that doesn't mean the other phases don't have value too. So the assumed breach model is just saying, hey, this is the greatest business value component. It doesn't necessarily mean that the others don't have value. So just from a priority perspective, that's what we recommend, but the others do have value, and it's worth putting those in context to what your priorities are. The second point is that you can do a purple team on any one of these phases. Assumed breach is just our recommendation. Since it's 2021, we can't talk about assumed breach without mentioning SolarWinds, right? So SolarWinds is the greatest example of why, well, there'll be another one maybe in the next week by the time this actually gets published. But for now, SolarWinds is yet again another reminder, as if we needed another reminder, that a determined adversary will get in. You will be hacked. The old adage is there's only two kinds of companies: those that have been hacked and they know it, those have been hacked and they don't know it. The point is that the concept of the perimeter, and particularly with the increased adoption of cloud in the 2020 shift to most of us working remotely as enterprises, is that the adversary will get in. Again, this ties to why the assumed breach model has value, is we know it will happen. And so being able to focus on the elements that we can control gives yet again more value to that.
So as far as executive summary here, we had systems that were the same baseline throughout the entire 6 weeks. We did all our original baseline testing there. And from all these adversaries, 94% of those TTPs, of those adversary behaviors, were not detected at all, not even logged on the local endpoint. 3 test cases were detected by the current controls, and 1 test case was blocked. So the result was that any of these threat actors would have been successful attacking this organization from the assumed breach perspective, gain their objectives without being detected. Now we did a little bit of work, and that work was with Sysmon.
So Sysmon is a free driver that Microsoft publishes, and you can see here on the date, they're actively maintaining it and updating it. The latest version adds an additional event ID that allows logging of process tampering. Actually, I believe we give out a couple of shouts to him because he's also one of the smartest folks in cyber, but Olaf Hartong does a lot of great work on Sysmon. He publishes automated, configuration called Sysmon Modular. Highly recommend check that out. But the key here is, again, starting with visibility and logging. Sysmon is this ability for me to, for free, push additional capabilities into Windows event logs that's going to be able to track all sorts of different things, from process creation, network connections, changes to the things. Like I said, I think there's like 24 or 25, because I get mixed up between Sysmon 12 and 13. Different event IDs that allow a level of granularity. And then where it starts to get really cool, which is what we're going to be showing you here, is taking the very limited detection of what Sysmon can give me at a granular level, and then starting to put context around it. And then it gets a lot of fun when you're able to identify TTPs by marrying different Sysmon event IDs together, because that's indicative when we're able to see that of an attack in progress.
So the end state, again, just still an executive summary, just hopefully you're still with us. With $0 technology spend, we were able to achieve 64% detection rate of those same TTPs. And we did that by enabling telemetry with Sysmon, as Bryson just mentioned, as well as sending those event logs to a central log aggregator and creating logic to then create alerts and trigger responses with a tool that they already had and they use. It's a SIM called Event Sentry. So thankfully that was already deployed. Our work was mostly around detection engineering, enabling the telemetry and creating that logic. So at the end, you can see, obviously we didn't get to 100, and rarely will you ever get to 100. There's no such thing in security. But we did see significant improvement from our baseline, and all of these known threats and these known behaviors would have been caught at some point and responded to before the adversary achieved their objective. So hopefully you're with us still. We're going to go through a ton of slides. Again, all of these have references and they are going to be posted so you can read through this. But pretty much NMFTA came to us and said, look, we do our yearly pen tests and we do vulnerability scanning and we have some good patch management, but we want to test actual adversaries that are likely to attack us and see what they can do. So we leveraged cyber threat intelligence, understood their organization, what threat actors are likely to attack them, proposed those threat actors, and created adversary emulation plans. And then we did all of this in the production environment, because the production environment is where all of their security tools and responses were. And of course, $0 increase in technology and in tools was the most fun thing to work with there. So shout out to Katie Nichols and Cody. They presented this this process for leveraging cyber threat intelligence, doing adversary emulation plans at SANS Summit in 2018. I don't know where the URL went. I did have it up there. But pretty much they mentioned that you need to first understand the target organization, then identify the adversaries, gather threat intelligence on that adversary, extract the behaviors, the TTPs, analyze and organize those, and then create an adversary emulation plan. So that's exactly what we did. For the Purple Team exercise, pretty much every week, we would present the adversary we were going to emulate along with the TTPs of that adversary and all the technical details. We would then discuss in a tabletop with some of the stakeholders and attendees from the target organization, just to understand what their expectations were, what they thought would be caught and what they didn't think would be caught. Then we emulate the various TTPs. We would then perform the blue team function of actually seeing if there was any detection and if there was any response. And throughout this, you'll see that there were times that I'd get a text message saying, hey, I see you, I see what you're doing, which was great. But other times we would not get any logs. So we would go through that each week, different set of adversary TTPs, all chained together. And really the work was around tuning the security controls, enabling that telemetry, enabling the sysmon configurations that would catch those adversary TTPs, ensure that those logs were being sent to Event Sentry, and then ensuring that there were alerts and an actual response. So what are TTPs? And shout out to David Bianco and the Pyramid of Pain. TTPs are that top of the pyramid, the toughest thing to detect. Everything under there, it's a little easier, starting all the way with hash values, IP addresses, and domain names. Pretty simple things that most organizations can quickly detect and leverage as indicators of compromise. But really, when we get to adversary behavior part, that's the tougher part to actually catch. And that's where we wanted to focus on. So why is detection hard? Again, shout out to Anton and this blog post that really specifies that detection is difficult. It needs people and it needs data and it needs context, right? So just as Bryson mentioned, a screenshot is not necessarily bad, right? We all take screenshots, but a screenshot when it's coupled with a few other adversary behaviors altogether should probably be correlated, detected, alerted, and responded to. And that last point here is detection is about intent. That is the toughest part to know. What was the intent? Because of course you have malicious insiders as well, right?
So Detect, I want to give a shout out here to Marcus Baker. He created this concept, and I really liked Detect because it does a couple of things. First of all, the visualization here where we're marrying intelligence and blue team with a, the node graph here of how things come together. But fundamentally what we're looking at is in the blue team perspective, what are our data sources? What visibility does that give us? And then tying it to what am I able to see? Which of course fits across what we're building out with the purple team with this collaborative milestone approach of generating what I call functional signal, AKA an attacker, against all of these blue team sources and the process and people of them.
So as mentioned, Scythe came in to play all three roles of cyber threat intelligence, red team operator, and the blue team for doing everything from detection engineering to ensuring that there was a response process. I acted as the exercise coordinator, which if you do run purple team engagements, I highly recommend you have an exercise coordinator with some experience in project management. If you're just getting started, then yeah, you're gonna have to do multiple roles, and that's totally fine. And then of course, internal operations, we had our sponsor and attendees there watching what we were doing, which was a great learning experience for them as well, because they built a process. Once we leave, they can continually test a lot of these behaviors and continue to evolve as new threats are released and new adversary emulation plans are released. They can test for those. So from a planning perspective, we did use Scythe. Don't want to talk too much about the platform, but it is an enterprise grade command and control framework that allows us to automate those attack chains. So we can create adversary emulation plans and share those plans with the community of actual attack chains that have been seen in the wild by our other teams that do incident response. And then target systems. We did all of this in production. And yes, I am a big believer we should do this in production. I was able to convince a large financial that we can do all this testing in production, and they move trillions of dollars in a day. So if I was able to convince them, I think you can convince other organizations to do the same. It's all about building reputation and not bringing down their systems, right? Availability is important. This is one of the reasons why we like using enterprise products. So we asked for multiple systems. Their endpoints were all Windows 10 and their servers were all on one version, believe it or not. So going into this, we're like, wow, they're actually pretty up to date. They have good and the latest operating systems. We knew a little bit about some of their pen test reports and seeing that they were pretty good. So we got a standard user. We got, which was also a jump point for us, VPNing on all that fun stuff as we do baseline, assume breach. Then a standard user for testing the baseline, and then a system where we were local admin, and that was because of sysmon and enabling configs. We want to be agile there, and then a standard system on the server. We also got, yep.
Oh, sorry. You finish this part, then I'll add on the production environment. Sorry.
Perfect. Then we created production accounts in Active Directory with email access and all that fun stuff. And we made sure that all these systems had the standard security controls, right? In this case, we're not going to call those out, but they had their standard antivirus firewalls, SIM with Event Sentry, and lots of email security, actually pretty impressive. Go ahead, Bryce.
Yeah, too much coffee and an excited unicorn. So the production environment piece, production versus lab. So of course, doing it in production has risk. And it's important to understand your configurations and to test things in a lab environment before pushing to production. But the fear of affecting production costs you a lot of what you're going to get from the efficacy of running one of these assessments. The first point about your defensive controls are tuned for a production environment. EDRs will catch everything in a lab because it's an artificial environment. Turns out that we've seen this time and time again in security, that does not work in production. Because if you get in a user's way, you're going to turn the user, the employee, into the greatest hacker ever. They will do anything they can to circumvent a control that gets in the way of them doing their job. So things are tuned for the production environment. The other thing you get out of a production environment is you're bringing people and process into the loop. In a lab, you're solely going to be looking at almost a checklist of technical controls and understanding. You're missing the dynamic surface risk of what your employees do. You're missing an understanding of how policy and people work with the tools with your IT security organization. And then of course, you're missing what really is happening in the real world with how those defensive controls work with production.
Yep. So the first week, as I mentioned, was baseline. Since we were playing both the blue team and the red team, we needed some situational awareness. So from the red team side, the first week, we created a campaign. We executed it through user execution and run DLL32, which are the two most common ways that things are getting executed nowadays. Then we established command and control over HTTPS, also the most common communication channel. And then we ran a who am I, right? Very, very basic for baseline, but this should have spawned some sort of logs, some sort of alerts, right? And that's what we wanted to see. We want to ensure that there was visibility, that the security controls were there, that there was local logging, remote logging, etc. So this was in our planning phase. This is a screenshot from Vector. So Scythe integrates with Vector quite well. It's actually 2 clicks to import this and have this view. So you can see there 5 different TTPs, run DLL32, C2 with HTTPS, running who am I, and Windows command shell. So after that run, we took a look at the detective controls and nothing was logged on the endpoint or the network. Sure, there was an outbound network connection, but no indication that that was command and control. So time to get to work because we are at 0% detection rate. So we implemented controls. We installed Sysmon that Bryson already covered, and we enabled event ID 1, which was process creation when any executable is run. And in particular, we wanted to see run DLL32, command.exe, and who am I? All things that run in a normal environment at any given time, right? So the next step was to send that Sysmon log to the SIM, which was Event Sentry, and then configure logic on the Event Sentry to only alert when these particular chains were ran, right? If you saw it run DLL32, followed by a command.exe or followed by a who am I, then let's take a look at that because those things happening in succession in, within a number of minutes of each other is kind of strange. And we set up email alerts to the operations team. This was their current alerting infrastructure. So this is what a event ID 1 looks like in Sysmon. In this case, you can see who am I there about 6 lines down. You can see the user that ran it. This was our Scythe user and the hashes and whatnot.
Yep.
And then the last thing is you can see the parent image. So we're actually seeing run DLL32.exe spawning who am I.exe. How often is that?
So run DLL32 is another great example of context and is another good baseline to use because it's part of LOBAS, right? This is things that would naturally be running in an environment, which of course, as an attacker, I want to take advantage of organic assets because that helps me blend it in. And so this is why we chose this as a good starting point.
Yep. And we leveraged Event Sentry, so shout out to them. It's not a free product, so sorry, we did mention Vector, which is free. This is what they were using. And thankfully, it already had native Sysmon integration. They had already set up log forwarding, which was great. We just had to enable certain things. It also had Active Directory monitoring, which we will cover in a bit. So we then set up the alerts. Again, they used emails for alerts, so we set that up. And whenever run DLL32 was ran, also with a who am I, there would be an alert. Very quick and easy, and really getting that process in of emulate some bad stuff, figure out how to detect it, and then turn on the alert. And at the end of that first week, we had detected 4 of the 5 TTPs. So a lot prettier pie chart here, something that you can probably show off, that you're up to 80% detection in the first week was a great start. The second week, we took a look at APT19. This is a low sophistication Chinese-based threat group that has targeted everyone. They generally focus on enumeration and maintaining command and control. So we go through, and we do this on Threat Thursdays as well, where we analyze these threat actors and we create these attack chains. So you can see here, there's a few more TTPs that we tested. And of course, seeing it in the table is easy, but seeing it all nicely in a vector diagram that we imported looks even better. So you can see here, C2 via HTTPS, which we had already tested, and then a lot of discovery, right? Generally, once a threat actor gets in, their next step is situational awareness. So we went after discovery next, and a lot of LOL basses, right? A lot of living off the land with things like ipconfig and net and ARP and WMIC, sysinfo, reg, and a little bit of collection as well. So going back to our original baseline, 0% detection again. In this case, we wanted to enable a few other things. So with that system event ID 1 of process creation, we can turn on other things like ipconfig, netstat, directory listings, net shares, net views. We also turned on sysmon event ID 3, which is network connections. Now, this is a very valuable one because it shows all outbound connections, or really all network connections being established. And you can use that with other indicators of compromise to know if something bad has occurred or someone has communicated with a known bad IP. We also enabled file create. That's event ID 11 on sysmon. So this uses endpoint detection tools to help identify any known malicious droppers or executables that were created on the system. And then we got PowerShell. And Bryson gave a very good quote there, and I'm going to modify it a little bit, that there's 2 types of people: those that know that there is PowerShell in their environment and those that don't know that there is PowerShell in their environment. And that's exactly what happened here. You know, we tabletop everything at the beginning and we say, hey, we're going to use PowerShell.exe. Do you use PowerShell.exe? And they said, no, we do not use PowerShell.exe for anything. No one should be using that. We said, okay, we'll turn on sysmon event ID 1 for PowerShell.exe. And we got hundreds of alerts almost immediately. See, they didn't realize that they do use PowerShell.exe. And this happens, I would say, 99.9% of the time. Very rarely does someone really not use PowerShell.exe. So we had to find out what actually used that and then tune that alert. Only alert when there is PowerShell.exe, but it's not these known processes that are part of the infrastructure. And then this required us to test quite a bit, because first we had to enable the log locally, then send it to Event Sentry, then turn on the alerts, then tune the alerts. And here's what it looks like. We created a little quick threat there that just runs PowerShell who am I and runs PowerShell with encoding. Again, that's who am I. You don't have to decode that in your head. Very easy, but very simple to repeatedly test. And you can see here how many times we tested for that very, very simple PowerShell.exe. So at the end of the second week, we're up to 73% detection. Week 3, we did Bottrap. This is a medium sophisticated Russian threat group that did a little bit more than just discovery, did things like persistence and defense evasion and execution of other things. They also did C2 over DNS and RDP. Remember, up till now, we've only tested HTTPS. So this is what it looks like in the planning phase: C2 via DNS, via HTTPS, and via RDP, some discovery, and then lots of new things in the collection side, right? Stealing from clipboard, keyloggers, etc. So while most adversaries operate over HTTP and HTTPS, adversaries sometimes use DNS. It's not the quickest, right? But it's good for long haul. And lately, of course, we're seeing RDP as well. And we also have a module that leverages Rob Fuller's or Muvix's "Let Me Out of Your Net," which is great for testing multiple egress points from inside your network. So we took a look at this, and it actually was blocking DNS outbound. We thought that was fantastic. We gave each other high fives, and we let them know that they blocked a particular C2 method. This is great. It's important to share the wins and to understand why they are there, do root cause analysis, and see how you can apply those wins to other things. So we did find remote desktop outbound, and that should not have been there. When they saw that, they immediately looked at each other and said, no way, no. And they went off. They didn't share their screen, but within a few minutes, they actually came back and said, test that RDP outbound again. And we did, and it was fixed. It was fantastic. It was a configuration that was modified. It was done on the fly and was forgotten about until we actually tested it. So for detecting command and control, again, Sysmon Event ID 3 for network connections and monitoring that outbound connection. Now, there was an area where we didn't do too well in, and that was monitoring Windows API calls. Things like key logging and clipboard access and screen prints. And now, before you tell me that, yes, Sysmon now catches clipboard, which is true, that update came out towards the end of this assessment, and we were not and did not have the time to go back and enable those live for this particular assessment. So what did detection look like at the end? 60% detected, still had that block on DNS and RDP, as well as some things not getting detected. Then week 4, APT33, this is an Iranian threat actor. This one, or pretty much any Iranian threat actors, became pretty popular in early 2020 after the assassination of Soleimani. We were in heightened alert of Iranian retaliation through cyber. So this planning, you can see this threat actor is a little bit more sophisticated, does a lot more TTPs. There are going to be some repeat TTPs, but again, that's totally fine. Actors will repeat things. But you can see things there like running scheduled tasks and creating scheduled tasks. It's a great way for persistence. We did the test, and guess what? There was detection for scheduled tasks. When we created them, immediately one of the attendees received an alert on their email that there was a brand new scheduled task created on a system. We again gave each other high fives and said, that is awesome. But 88% was not detected. So here, looked up some more PowerShell, more command prompts, and then enabled some other event IDs like file creation and registry modifications. So registry modifications are tough because the registry is touched all day long by pretty much everything that's going on. So the tuning for it becomes quite difficult. There's actually 3 different event IDs, ID 12, 13, and 14 for various registry modifications. And we had to look into those and tune those to only alert on certain modifications. So which ones did we want to monitor? Things like startup activity and stored credentials and accessibility features for things like input and image capture, right? We couldn't enable everything because there was a lot of noise. So at the end of that week, we were at 58% detection for APT33. Then we did APT3. This was a pretty well-known Chinese cyber threat actor. Again, lots of execution, collection, some exfiltration, no detection going to back to our baseline, and then enabling other things, right? Still having those issues with the API calls, but we were able to detect exfiltration with Event ID 18 for creating remote threads, as well as file creation and network connections. So a bit of tuning there and back up to 71% detection. And then on the final week, we had what's called free play. Free play is that based on the previous 5 weeks of work, what areas do we think we need to focus on? Well, 2 critical vulnerabilities had come out. You might remember these. Feels so long ago, but this was probably less than 6 months ago. There was zero login on Windows domain controllers, and Microsoft Exchange had a vulnerability. And we really didn't spend too much time looking at the domain itself or doing lateral movement. So we came up with a plan for that. One of the things we ran was Bloodhound, and shout out to the developers of Bloodhound. And what it does is it queries your domain controller as well as machines in your environment to discover users, groups, machines, ACLs, etc. You then take that information offline, and it has this beautiful visualization platform that allows you to see who's connected to where, and you can do queries like, what's the quickest way to domain admin? And as we ran this, there was no detection for the actual queries, but it's really more information gathering, but we still worked on detections. And we found that there were some standard users in the enterprise admin group. This is generally not good. We notified the stakeholders immediately for this one. They weren't watching as we were doing it. So we called them up, and this was another one that was resolved within minutes. Then we took a look at some of the vulnerabilities that had recently come out. They said they had a good patch management policy and process. So we tested it. We wanted to see if they did indeed patch for these critical vulnerabilities, and they had, which was great. It was great to verify that. Again, high fives all around. Then we attempted lateral movement. They had invested significantly in network segmentation. So we tried doing some lateral movement through a number of different ways, and a lot of those were blocked up to the extent that we tested, which was good, and we were able to share that good news with them as well. Then we did some Kerber roasting. Kerber roasting is and was discovered by Tim Medine of Red Siege, so shout out to Tim. It's the ability to request service tickets for services that may have existed at any time or currently exist in Active Directory. The way that works is you contact the domain controller. It's how Kerberos authentication works, which I'm not going to go into, but pretty much you ask that domain controller for a service ticket. It provides you that service ticket hashed. You can then grab that ticket and crack it offline. And we did find a particular account that was Kerber roastable. I think, oh no, didn't cover on the other side. We don't mention what account that was, but ironically, it was a security tool account, and that was an interesting one to see fixed. We did other things internally like port scanning, which is quite basic, but I only highlight this one because we scanned a honeypot. And this is when I got an immediate text saying, hey, how's your free play going? I see you. I'm like, oh, cool, good job. So we documented that as a win. We then did some exfiltration. We created a fake 2 gig file and exfiltrated it. There were no alerts triggered. A lot of the network visibility on the network side was lagging here because there was no net flow to analyze the data. Now, Event Sentry does have a module for that, but they had not purchased it yet. So this was one of the recommendations. However, we did not enable it, keeping true to not spending any money on this assessment. So at the end state, as I mentioned earlier, $0 technology spend, purely process and people. We enabled telemetry, we enabled logic, we created response plans, and 64% detection rate for these known adversary behaviors that we tested. But more importantly, what we built was a Purple Team program that they will now be able to continually test for. Using Vector, we get nice historical trending. The reason it goes down every week is because we go back to the baseline every week. But you can see here towards the end, we're definitely up to a rate that that they liked and that they can improve on. So our recommendations here were to continue testing, make sure that things don't change, right? We actually detected that RDP that shouldn't have been allowed outbound, and they were able to fix quickly. They should consider network level detection, particularly around net flow, which is probably the best bang for your buck. And then as new threats come out, take the adversary emulation plans and test them against yourself. We actually publish all of these for free to a community. It's the largest public library of adversary emulation plans. This is an old screenshot. We update things quite frequently. The latest one is a Gregor, which is a brand new threat actor, has been around only a couple of months. So if you're interested in the latest and greatest, by all means, check it out.
And if you're in threat intelligence or offense, we love collaborating on doing those and helping present them. Use attack and detect as a guide. I cannot emphasize enough that while it's easy to get caught up, because in security, we don't get to have quantitative metrics very often. And folks love to look at attack and go, well, that's my bingo card to just cover as many of them as possible. And look what I've done. The same thing on looking at that detection graph, where we see it trending. You're not going to get to 100%. It's not possible to get to 100%. And if you ever somehow achieve that, you've either got an environment that is so over-engineered or you've spent way too much time on it. The key thing here is finding your detection average. What is that natural percentage that makes sense in your organization? And nobody can give this to you. You have to go through this process to find what that is. And over time, you'll get there and you'll be able then to react as things change in your environment. So the ability to continually assess that percentage, which there are tools to help you do that, will give you a natural feel for how it's going. The other thing I want to talk about here is that this was, as much as this was like overall a 2.5 month engagement with 6 weeks of focused on the ground, we really only got as far as building out a strong, effectively using detect as a guide, that data sources, detection, and visibility. The next step, which credit to Dmitry Alperovich, is what's called his 1-10-60 rule. And what we're looking at here is taking it even further to understanding response times, because what he was getting at is when you look at being able to contain what's called the breakout time of an adversary, that's, once they got shell and start doing something, the clock begins to tick. The more time that they are there, the more damage and the further they can get. And so what you want to be able to do here is now taking all of these things we've put in place in a mature environment and starting to go, okay, when did my tool see something? When did my team see it and be able to respond to it? That's that difference between logging and alerting. How long did it take them to respond and fully understand what the attack is doing and what's the scope? And then finally, how long does it take to control and remediate? And so the 1-10-60 was a guideline for this is the vision of what you want to achieve. Again, results may vary, but very much the next step.
So we really believe in sharing things with the community. It's in our DNA. So, even though we use Scythe and we don't want this to be a sales presentation, we do have a lot of free resources for you. One is the Purple Team Exercise Framework. It's free and available at PTEF. The other thing is our workshops that we host all the time. We're going to be hosting it right after this and about an hour after you watch this, if you watch this live. So come on out to that. It's hands-on, it's free. We have an environment for you where you get to play CTI, red and blue. We also provide all the adversary emulation plans we create with community help. I mentioned it, Gregor, working with Sean Gallagher from Sophos on that one. On our community threats GitHub, again, those are all free. You can take a look at those. We provide them in JSON format and also in Attack Navigator JSON. The Sysmon configurations are free. Shout out to Olaf and Sysmon Modular. And if you do use Event Sentry, they will be providing all of that alert and logic we created as well. in a blog series that they're pointing. So again, thanks to NMFTA for allowing us to share this use case. Hopefully you found this valuable and it's something that you can do. And of course, we try to keep it at as least salesy as possible, really focusing on the technology and on the process that you need to create with your people to continue and be able to defend and detect and respond to these evolving threats.
The Purple Team Exercise Framework is a living document. We already have plans in the works to bring in additional community partners and update what we've learned from it from a process perspective, and continue to share that out for free for everybody as a resource.
That's it. Thank you very much. We will take questions on Discord. All right. Stop recording.